All right, guys, section 10.4 today, the discriminant. So when solving quadratics, we're going to be looking at a method that works for any quadratic, whether they are uh, factorable or not next week. But today we're going to learn about something called the discriminant. So before we do that, we're going to look at, again, to remind ourselves the definition of imaginary numbers, because this is going to be part of this um, discriminant that we're looking at. So remember, if I have the square root of a negative number, that number, I'm still going to take the square root of b squared as normal, but that negative tells me that this is an imaginary number. So the square root of b squared would be b, but because of that negative underneath the square root, I'm going to need an I with that. So it's going to be bi would be the answer here. It's the same as the square root of -1, which equals I, times the square root of b squared, which is b. So just kind of a little reminder there. So for example, if I had, let's say, the square root of -4, the square root of 4 is 2, and because of that negative underneath, that would be 2i. Okay. All right, so the quadratic formula is the method we will use to solve any quadratic. We're actually not going to do it this week, we'll do it next week. But a really important piece of that formula is b squared minus 4ac. So in the quadratic formula, the whole thing looks like this: negative b plus or minus the square root of b squared minus 4ac all over 2a. So this is how we find our solutions to any quadratic function. This discriminant is just this piece underneath the square root, the b squared minus 4ac. And because it's under a square root, we can tell which type of solutions the quadratic has. All right, so let's go ahead and take a look at the next slide here. Oh, there's the formula. I thought it was there. Okay, so if my discriminant, like if I calculate the discriminant, that b squared minus 4ac, by the way, in that formula, any quadratic is in this form, right? ax squared plus bx plus c. This is standard form for a quadratic. We always want the x squared term first, then the x term, and then the constant term. But the a, b, and c in that formula come from a is in front of the x squared term, b is in front of x, and c is the constant term. So whenever you're trying to find a, b, and c, make sure your quadratic is in standard form like this. So when it's talking about that b squared minus 4ac, that's the discriminant, if that value ends up being positive, so I take the actual number that's here for b, like let's say it was 3, and I square it, and then I subtract 4 times a times c from that. Once I evaluate it, if that discriminant ends up being negative, that means there are two imaginary solutions. If I calculate b squared minus 4ac and I get 0, that means there's one real solution. Now, technically, every quadratic has two solutions because we have squared on our x. So there actually are two solutions every single time on a quadratic. The one real solution is actually a repeat solution. So it has one real solution, but it happens twice. So technically it's still twice, but we just call it one real solution because they're both the same. Now, if my discriminant ends up being a positive number, that means there are two real solutions, right? This is under a square root in the formula. So if I take the square root of a real number, I get real solutions. If I take the square root of a negative number, I get those imaginary solutions. So that's why if the discriminant comes out negative, I get two imaginary solutions. Okay, so let's do some examples. Oh, before we do that, let's look at the graph. So this is the graphic representation of this, how it looks. So the number of real solutions, and remember sometimes we call those solutions zeros, is at most 2. So there are 2 for each one. If there are two imaginary solutions, the graph looks like this first graph. The quadratic, the U shape, does not touch the x-axis and will not touch it. So this one is opening upward. It's above the x-axis. There's no way that's ever going to come across the x-axis. It could also be down here, opening downward, that one would also have two imaginary solutions. On the graph, if they don't touch that x-axis, that means it has two imaginary solutions. That means the discriminant would have to be negative, right? If it's negative, it has two imaginary solutions. And so that's the graph, what the graph looks like in that case. Now, if the graph, the U shape comes and touches the x-axis and turns back around, it doesn't actually cross through it, that's when we have one real solution. And remember, when we have one real solution, that's actually two repeat solutions that are the same. So it still has two solutions, they're just repeats of one another. So we call it one real solution. And in this case, the discriminant would be 0, right? This is from the chart we had on the other page. If the discriminant is 0, then we have one real solution that's going to come and touch the x-axis, but it's not going to cross through. When it has two real solutions, those solutions are actually going to be the x values where it crosses. So the two x-intercepts on this graph are the two real solutions. So that's how you can tell if there are two real solutions, is if it crosses the x-axis two times. And in this case, the discriminant is positive. Okay. All right, so now we have our discriminant up here in the corner. For our first example here, we want to find the discriminant and use it to determine if the equation has one real, two real, or two imaginary solutions. So here's my equation, 2x squared plus 7x minus 11 equals 0. So the first thing to notice about this is that this equation is in standard form. We have 2x squared plus 7x minus 11, so we need to now find a, b, and c. So a is equal to 2. Remember, a is always in front of x squared, b is in front of x, and then c is our constant term. So a is 2, b is 7, and c is negative 11. So we're just going to take these values for a, b, and c, and we're going to plug them into the formula for the discriminant. So b squared, b is 7, minus 4 times a times c. Now notice I wrote all my multiplications here with parentheses around them. I'm going to suggest you do that, and especially when you put it in your calculator, that you put these parentheses around everything. It just makes a lot less mistakes with negative numbers and things like that. So 7 squared is 49. 4 times 2 is 8, and 8 times 11 is 88. Notice I have a negative times a negative here. So this is going to be positive 88. So let's make sure that's right. Yeah. So 49 plus 88 would be equal to 17, 8, so 137. 137 is the discriminant. This is a positive number, so the discriminant is positive. Because the discriminant is positive, I know there are two real solutions. Okay, let's try another one. Maybe we can get it to advance. Okay, so again, we want to find the discriminant and determine if the equation has one real, two real, or two imaginary solutions. A is equal to 8. Again, it's in standard form already, so we don't have to worry about that. B is 5, and C is 2. We're going to take these values and plug them into the formula for the discriminant, put parentheses around each number. So B squared would be 5 squared minus 4 times A times C. So this gives me 25. 4 times 2 is 8, and 8 times 8 is 64. So this would be 25 minus 60. All right, so 25 minus 64, let's see, that'd be 25, 35, would be negative 39. Just let me double check that that's right. And then since it's a negative number, negative 39 is negative, so it has a negative discriminant, which means there are two imaginary solutions. Remember, a negative under a square root gives me two imaginary solutions. Right? So remember, if there's two imaginary solutions, it's going to have that type of graph where I'm not sure exactly where it would be located on here, but it's going to be looking like this, and it's not going to touch the x-axis. It's going to have 0 x-intercepts. Okay, and this question didn't ask how many x-intercepts it has, but some of the questions will ask you how many x-intercepts it has. So remember, if it has two imaginary solutions, it means it never touches or crosses the x-axis. It would have 0 x-intercepts. All right, third example here. So notice here that my function here, or my quadratic, is not in standard form. We have an equal sign in the middle here. It's not equal to 0 on one side. So what we need to do is we need to get this 7 and we need to move it to this side. And we do that by adding 7 to both sides. So we would have 3x squared minus 13x plus 7 equals 0. So now it's in standard form. Now we can go ahead and find that discriminant. So a is 3, it's in front of x squared. B is negative 13, it's in front of x. And c is the constant term. So now let's go ahead and plug them into our discriminant formula, b squared minus 4ac. So I've got negative 13 squared minus 4 times 3 times 7. So 13 squared is 169. And negative times negative is positive, so it'd be positive 169. 3 times 7 is 21, and 21 times 4 would be 84. So 169 minus 84, I guess I'll just be accurate and use my calculator. So 169 minus 84 is 85. So 85 is a positive number, which means there will be, two real solutions, right? If there's two real solutions, that means they have the graph of this type where it's crossing the x-axis in 2 points. So I would have 2 x-intercepts, because when there's two real solutions, it means it crosses the x-axis 2 times. Again, a side note, because you will have some examples that ask you how many x-intercepts there are, and then some that ask you what the discriminant is and the type of solutions that gives to you. All right, so find the discriminant. Again, use it to determine if the equation has one real, two real, or two imaginary solutions. This one is not in standard form, so first thing we need to do is put it in standard form. So I can either subtract x squared from both sides, or I can add 36 to both sides and subtract 12x. Either way will work. I'm going to add 36 to both sides and subtract 12x from both sides. So those both go to 0 on this side. Over here, I've got to make sure I put this in the right order to be in standard form. So x squared would go first, negative 12x would go second, and then my constant term. So now it's in standard form. So a is equal to 1. Remember, if I don't see a number in front of x, it's a 1. B is equal to negative 12, and c is equal to 36. So let's go ahead and plug those in. Remember, our discriminant was b squared minus 4 times a times c. So in our case, b is 12, so negative 12 squared minus 4 times a times c. So 12 times 12 is 144, and 4 times 36 is equal to also 144. So 144 minus 144 equals 0. So because my discriminant is 0, I know there's one real solution. Okay, again, it's going to actually have two, but they're the same. They're both the same solution. So there's one real solution. I guess it's not one real solution. That's bad grammar. So one real solution, and remember on the graph, that's the one that comes and touches and turns back around. It doesn't cross the axis, it just touches it in one point, so it would have one x-intercept. All right, that was our last example. So good luck today, guys. If you have questions, please email me and we can get those taken care of. Have a great day.